that you have given us to share in your presence, Father. May we understand whatever that we are going to learn today, loving Father. Thank you, Jesus, for having enabled us to wake up early, loving Father, to attend this lesson. In the same vein, loving Father, may you give us the brains to understand. In the mighty name of Jesus, I pray and believe. Amen.
Amen. Thank you so much for the word of prayer. Uh, we are going to look at trigonometry. And as we start the session, yesterday we started on this topic, and I want us to have a recap. So I'm going to ask you in the chat to quickly type for me the what the the meaning of these trigonometric ratios. When I write cosec of x, tell me in the chat quickly. Just type, what does cosec mean? A cosec, what is its relation? Type in the chat what you think cosec x is equal to. I want its equivalency in terms of the known sine, cos, tan. When we put cosec x, what is it equivalent to? I don't know the members have got the question. So I want you to tell me that cosec is the same as 1 out of sine x. Thank you, Dorothy and Daniela. Good. Members, what about sec of x? What is sec x equaling to? What about sec? What? Thank you, Dorothy. So sec means 1 out of cos of x. Good. What about cot of x? What about cot of x? Aha, cot is 1 out of the tan of x. Very good. Yes. Now, as we go on with the topic of trigonometry, make sure that these ones are at your fingertips. And also when we write cot x, what about cot in terms of sine and cos? How can you write it in terms of sine and cos when you have cot? Thank you, D. They are said is the same as cos out of sine of x. Perfect. Now, make sure that as we go on with this topic, some of those things are at your fingertips. The moment someone talks about cosec, you know that is sine. Sec, that is cos. Cot, that is about what? Tan. And that's where now we are going to build up going forward. So allow me now to tell you that today we are going to look at what we call trigonometric ratios of those special angles. We have what we call special angles. And some of those special angles we are going to look at, we are going to first look at the first type. And here we are going to have what we call a right-angled isosceles triangle. That's what we are going to look at. And after looking at that right-angled isosceles triangle, we are going to go on and look at another one. We know about an isosceles triangle, and we know that an isosceles triangle will always have two sides that are equal. So I'm going to draw my triangle. I'm going to, let me see whether I will be able to come up with a good, uh-huh, yeah. So this is my triangle. And yesterday in our discussion, we agreed that whenever we are coming up with this, we need always to know where the hypotenuse is. So if this is our 90 degrees, what are we going to do? A right-angled isosceles whose two equal sides are of length unit 1. So here, members, and this side are going to be equal, and their length is 1 and 1. Now, what am I going to find? I'm going to be able to obtain what is my hypotenuse. Members, can we find the hypotenuse using your knowledge of Pythagoras theorem? We said that whenever you meet a right-angled triangle, that means that you must have the knowledge of Pythagoras theorem. Can we find our C, or what we call our hypotenuse for this triangle? Everyone is trying out to see what we are coming up with our hypotenuse. So don't forget, we shall use our knowledge of S squared plus b squared is equal to c squared. So you get for me, don't, Daniela is getting square root 2, good. Are we getting there? So we shall say 1 squared plus 1 squared is equal to c squared. 1 squared is 1 plus 1, which is equal to c squared. So we shall have 2 equals to c squared. So in order for us to get c, it means we shall get the root on both sides. So we shall have our c equals to root of 2. So here we shall have root of 2. Now, the next question I'm going to ask members, what do you think our angle is? These angles inside. Which angle do you think is inside there? Which angle do you think is inside there? Aaron, you are correct. Amara, you are correct. Now, my question is, which angle? This is an isosceles triangle. Which angle do you think is inside there? Hmm. Ben is saying 30. And here, remember, I want you always to remember, some of you, I know you are used to such. When two sides are equal, it means that the base angles are also equal. So this means it is A, it is A. So the same thing here, it means this is A and this is A. So you add up A plus 90 degrees should give us 180. So members, can you find out the angle inside now? Thank you, Daniel, 45. Ampulide 45, 45 Dorothy, Daniela 45, and Emma. Very good. So when you work out the mathematics here, you'll have 2a plus 90 is equal to 180. It means that 2a is 180 minus 90. 2a will equal to 90. Divide by 2, and that angle is 45 degrees. So that's how members are getting the 45. So inside there, we are going to have 45 degrees. So you are going to allow me that inside here, no matter the position, we shall have 45. So here you have 45 degrees. Now, when you look at our triangle, like we say that the side that faces the 90 is hypotenuse. So this is going to be our hypotenuse. The side that sits, this is going to be adjacent, and this is going to be our opposite, basing on the angle 45. Now, whenever they talk about special angles, one of the special angles is 45 degrees. This one we have. Now, like we said, we have what we call trigonometric ratios, and the first one is going to be our sine. And which sign are we looking for 45? So I will say sine of 45. But do not forget from your SOHCAHTOA that sine is given by opposite out of the hypotenuse. So members, our sine of 45 will equal to opposite, which is 1, out of hypotenuse, which is root of 2. Now, if you want, you can now rationalize such that you don't have a root. So in case you want to rationalize, you say root of 2 times root of 2 times root of 2. And therefore you remain with root of 2 out of root of 4, which will give us root of 2 out of 2. And members, the moment you place sine of 45, you'll end up with this. Yeah, on your calc. Now, what is your task, members? Can we go on and find what is cos of 45? Can you go on and find what is tan of 45? Members, can you go on and find what is cot of 45? When you get the answer, feel free to raise up your hand and you let us know what you are getting. Okay. K, you can. Okay. I'm going to start from Ian.
Cos 45 is root of 2 over 2.
Root of 2 out of 2. Okay. Thank you, Ian. Any other who's getting another one? Tan 45. What is cot of 45? Tan of 45. M is telling us is getting 1. That is from M. Uh-huh. Uh-huh. Yes, Daniel?
I'm getting 1 as well.
Okay. Uh-huh. What about cot of 45?
Cot also 1.
Cot also, you are coming up with 1. Good. Uh-huh. Members, what about cosec of 45? Get also for cosec.
Sec is root 2.
Uh-huh. You are getting root 2. Okay. What about, thank you, Daniel? Other members, what are you getting for? Oh, Mudea Aaron. Never write decimals. Never write decimals. The reason why we call them special angles, it is because you can get an exact value. One of the angles where you can get an exact value is 45 for whatever trigonometric ratio you are dealing with. So here we don't write decimal points, but we write that exact value you obtain. Okay. Akram?
Teacher, I have a concern on cos of 45.
Uh-huh.
Cos of 45, according to Socrates, it says cos of 45 equals to adjacent over hypotenuse.
Cos of
And in this
45.
case,
You have said
yes,
adjacent. Uh-huh.
over hypotenuse.
Which is, what is your adjacent?
Adjacent is 1,
Uh-huh.
and
Out
then
of?
hypotenuse is root of 2.
Okay. Uh-huh.
But here I
Continue.
see you had written as root of 2 over 2.
Oh. Now, Akram, why it is like this? Your answer is also correct, eh? But because
Yes,
someone has
please.
rationalized. So when
Mm,
you, this answer you get when you multiply by root of 2 and root of 2 down, that is the rationalizing. So 1 times root 2 is root of 2. Root 2 times root 2 is root of 4, and root of 4 is 2.
okay, please. Okay, please.
Okay.
Okay, thank you,
Members,
teacher.
okay. Cosec of 45, what are you getting? Cosec, someone is getting 1. Mm-hmm. Do we use the cot x to calculate cot of 45? Yes. Yes. Melissa, the moment you see cot, like we said, cot means cos of 45 out of sine of 45. Alternatively, you know that cot of 45, like we said, is the same as 1 out of tan of 45. So you can use the knowledge of any of that two. Yes, hope it is clear. But since you had already obtained tan 45 as 1, so that's why we can just conclude or use that one. Hope that is okay. People are saying cosec is 1. Okay? We know that what is cosec? Because that one we need to be very careful. We know that cosec of 45 is the same as 1 out of sine of 45. But what did we get for sine 45? When you come here, sine of 45 was something like this. So, members, it cannot be 1. It cannot be 1. Can we get it again? I don't know how members are getting 1 for cosec. Use the relation very well. Something is not okay. Root of 2. Perfect. Yes, it is root of 2. Because when you check here, check. Are you, Priscilla, yes. Yes, I agree now. Members have started. So remember, cosec of 45 is the same as 1 out of sine of 45. Now, when you substitute sine of 45 here, you'll have 1 out of sine of 45. So sine of 45, you know you get 1 out of root of 2. And members, this will give you root of 2. Alternatively, when you are dealing with a cosec, you can know that cosec can be the other round. I hope it will not confuse you. Cosec Now, for it will be hypotenuse out of the opposite. In other words, so it will be root of 2 out of 1, which is root of 2. Okay, members, in case you have a question, ask now. Yes, Mercy.
Excuse me, sir.
Yes.
On this part of cosec of 45, why
Mm.
are we using 1 out of root 2? Yet we had gotten root 2 out of 2 as our last answer of sine 45.
Anything, we shall come up with the same. Mercy, you stay on. Mercy, you'll have root of 2 out of 2, not so?
Yeah,
Which is the same as 1 divided by root of 2 out of 2. True?
yes,
Which
yes,
is the same as 1 times 2 out of root of 2.
yes.
So 2 out of root of 2. Remember, you don't want to write a root in your denominator. So you rationalize. Root of 2 out of root of 2. So 2 times root of 2 will give you 2 root of 2. Root of 2 times root of 2 gives you root of 4, which is 2. So the 2 and the 2 cancel. So you remain with root of 2.
Okay, thank you, sir.
Okay. Genesis?
Good morning, sir.
Yes, good morning.
So I'm just inquiring, like, I'm seeing here a quarter of 45, we are having cos of 45 out of sine of 45. I'm requesting for a pardon on that. I don't get that very well.
Oh, now this one comes from the definition. Did you attend yesterday's lesson?
A half of it.
So you'll go back and review because we say that by definition, when I have cot of any angle, cot is the same as cos out of sine. So this is from definition of what cot is. Because you know that cot of theta is the same as 1 out of tan of any angle. But you know that tan is the same as sine theta out of cos of theta. So when you do the mathematics, 1 divided by sine theta out of cos of theta, you end up with 1 times cos of theta out of sine of theta. So this is where it comes from.
Okay, thank you, sir.
Okay. Members, let me know through the chat whether we are good to continue. Should we continue? Okay, Anita says yes. Are we on the same? Okay, good. Now, whatever thing we have obtained, we are going to use. Now, the second one. So one of the special angles we have looked at is 45 degrees. Now we are going to look at another special angle. Now to get other special angles, we are going to use what we call an equilateral triangle. And you know that an equilateral triangle, all the sides of an equilateral triangle are equal. So this side, and this side are all equal. Members, in the chart, if all the sides are equal, it means that also all the angles are equal. Which angles do we have inside an equilateral triangle?
30.
30? Not yet,
No,
not yet, not yet.
45.
45? Not yet, not yet, not yet.
60.
Not yet, not yet, not. Remember, when you add up all the angles, you must be able to get 180.
And the angles that are in this triangle.
60.
Can be 30 nagamba not yet. 45
Nango.
now.
So from the chart, people are saying 60. Very
60.
good. Remember, if this angle is A, this one will also be A, and this one is going to be A. So that means A plus A plus A is equal to 180. So we shall have 3A is equal to 180, divide by 3, and your A will equal to 60 degrees. So that's how we come up with our 60. So meaning that all angles, when we have an equilateral triangle, the moment we are equilateral, it means that all sides are equal and all angles are going to be equal. Now, I'm going to come up with my triangle. So I have my triangle here, whereby all the sides are equal. My sketch may not be the best, but for you must come up with a better one. come up with a better one. So I'm trying to see how I can come up with a better sketch. That's what I've managed to do. So since we have said all sides are equal, it means that also all the angles we have are going to be equal. So this is 60 degrees, this is 60 and 60. But what have we said? We have said that if all the sides are equal, here we are using 2 units. So that means that here we shall have 2, we shall have 2, and also here we are going to have 2. Now, inside an equilateral triangle, we can divide it into 2 equal parts. So when I divide here, I have divided into equal parts, meaning that this part here and this part here are going to be equal. Members, what is going to be the length from this part up to here? What will be our length? Put in the chat quickly. What is the length? People are saying it is 1. Perfect. So that is 1. Members, now we look at the angle. Thank you. Members, we look at the angle. Tell me, which angle shall we have in this area here? Here, up, up, up. Shamis says 30, 30, 30, 30. Very good. So the angle there is going to be 30 because initially you had 60 degrees. When you divide it into 2, you get 30. 60 divided by 2. Now you're going to allow me now. I'm going to extract one right angled triangle. I'm going to extract this right angled triangle of this nature. And what am I going to have? Here, I'm going to have my 60 degrees. Here, members, you are seeing I have 2. Here, I have 1. And here, I have 30 degrees. And here, you have your 90 degrees. Now, what is the task? The task, members, is to help me find out what is the distance here, what is the length of our height. Let's use our knowledge of Pythagoras theorem and find out what is the height. Calculate, calculate, work it out, work it out. Okay, I'm seeing some answers coming in. Someone can quickly take us through. Make sure you work it out. Don't guess. Yes, Amara.
Yes, so teacher, how the answer came about, what we needed to do, we're supposed to use the method of Pythagoras theory, which is stated as a squared plus b squared is equal to c squared.
Okay.
After that, you continue and you replace. So the a squared would be 1 plus b squared, a squared would be 1 squared plus b squared is equal to 2 squared.
Okay. Continue.
So teacher, after that, so it would be 1 squared plus b squared is equal to 2 squared. So as we continue, you're going to get 1 plus b squared is equal to 4. So then it would be 4 minus 1, that would be 3. So b squared would equal to 3. So b, after that you cancel out the square of b by putting a square root. Then you put a square root also on 3. Then b will equal to square root 3.
Okay, perfect. Thank you, Amara. So, members, here we are going to place our root of 3. Now, on our special angles, we are going to add. Special angles are those angles where you can get the exact trigonometric ratio without getting points. You can get the exact value. So on your angles, the first one was 45. So we are going to add on a 60 and we are going to add on a 30. Now we start. Cos of 60 degrees. What shall we have? Now, if I'm dealing with cos, I want you always to, you label it very well. Where the angle faces is opposite. This side is going to be the hypotenuse. This side is going to be adjacent. So what is going to be our cos of 60? Members, put it in the chat. What is your cos of 60? Gertrude, Abenaitwe, Ian. People are saying it's going to be a half. Thank you. Go on. Can we also get sine of 60? Eh, we shouldn't leave you behind. Okay. Root 3 out of 2. Very good, members. In case we are leaving you, Aaron, I don't know what question you have. Aaron, I'm not getting your question. I'm saying, Aaron, you may ask. Members, we continue. As Aaron, you ask, tan of 60. Aaron, ask.
Course,
Tan is.
like,
You are
can
saying?
you get something?
Continue. Okay. So tan, people are saying the answer is root 3. Very good. So we have been dealing with the cos 60. Now, what about, allow me to remove these ones. And I'm going to allow you to label for yourself. I'm not going to label for you. But you are going to tell us. Members, I'm looking at 30. You tell me what is on our opposite for 30 degrees. Which value is on the opposite for the 30 degrees? Oh, very good. Members are saying our opposite is going to be here. Members, what's going to be our hypotenuse? What is on the hypotenuse of 30? People are saying 2. Very good. That's perfect. So members, can we now go on and find sine of 30, cos of 30, and tan of 30? So go on and find all those ones. They are trigonometric ratios. Okay. Okay. Okay, I'm seeing the answers. Okay, sine of 30, people are getting a half. Cos of 30, people are getting root 3 out of 2. Tan of 30, people are getting 1 out of root of 3. Or people can rationalize and have root 3 out of 3. Okay. How? Yes. Now, remember, tan of 30 is given by, tan is given by TOA, opposite. So your opposite is 1, and adjacent is root 3. So when you rationalize, you'll have root of 3 out of root of 3. 1 times root 3 is root 3. Root 3 times root of 3 is root of 9, which is 3. So that's how it comes about. Tan 30 is 3 out of 2. How? Amara, check out. Okay. No, I don't know which one all of 1 out of root 3 and root 3 out of 3. It is the same thing. You get the same answer. So both of them are correct. And both of them are correct. After rationalizing, yes, all of them are correct. But the best is the one where you don't have a root in the denominator. It becomes easier to work out with. Okay, members, let me know. Sine. When you look at sine, sine of 30, sine is given by opposite out of hypotenuse. So your opposite for 30 is 1. Hypotenuse is 2. So that's how we are getting it. Oh, okay, okay. But still, Amara, I don't know where the 2 is coming from. Okay. All answers are correct. All answers. I don't know whether something is confused. Kindly ask. Okay, I failed to get her. Hatim?
Sir,
Yes.
but the opposite, I'm saying it's root 3. And here for the sine 30,
For
we are
which
having
angle? Which angle are you looking at?
for the sine 30,
Which angle is facing 30? Look very well.
it's 60.
Here. No, you look at the
Oh,
length.
okay. It's 1.
Yeah.
Okay, thank you, sir.
Okay. Pascal? Okay. Members, are we on the same page? Let me know through the chat such that we can continue. Pascal? Okay. Okay. I failed to get her, but from the chat, members are saying we are on the same page. We are on the same page. So we are going to continue. Now, all what we have looked at, members, we are going to apply. We are going to apply them. Now, where are you going to apply? You are going to be working out some numbers. You'll meet scenarios and they will tell you that give your answer in an exact form. When they tell you to give it an exact form, you will notice that sometimes there are some angles that are special that have been given to you, meaning that your answer, you leave it in the third form. So they don't want you to write in points. So we are going to apply all what we have looked at. So allow me that we are going to start from here. So what am I going to do? I'm going to draw, like I've said that always I want you to understand the concepts. Don't cram, because when you cram, you may mess up. So here we have two angles. We have 30 and 45. So for 45, we use our isosceles triangle. So I'll have 45. I now have 1. I have 1. I have root of 2. Then since I have 30, you use the isosceles one. So you still come up with your simple sketch that this is my isosceles, whereby I have here 2, I have 1, I have root of 3. And here I have my 30. Now, when they tell us to find the exact value, they have told us to find the exact value of sine of 30 and cos of 45. What does it mean? Substituting the way you have them. So sine of 30, I'll come here and I say Sine of 30 is given by opposite out of hypotenuse. Cos of 45 here, you say cos of 45 is given by adjacent out of hypotenuse. So you substitute in these values. So sine 30, I'm going to put a half times cos of 45, I'll put 1 out of root of 2. So mathematically 1 times 1 is 1 out of 2 times root of 2, which is 2 root of 2. So you can continue from there. If you want to continue from here, you can now go on and rationalize. So when you rationalize, you'll have 1 out of 2 root of 2 times root of 2 times root of 2. So what shall we have? 1 times root of 2 is root of 2. Out of here, we shall have root of 2 times root of 2, which is root of 4, root of 4, which is 2 times 2, which is 4. So you get an answer of that nature. So you can end here or here. So that is how you express it in an exact form. Where are you getting the root of 2? No, members, now remember, whatever now we are doing, we are applying from the start. The first thing we looked at, you go back and look at at what we started with. When this is 1 and this is 1, to get hypotenuse, use your Pythagoras theorem. We are using those two triangles we looked at first. Go back and look at the first diagram we had. Let me hope that is okay. The root of 2 Samsung, look at the first right angle triangle we looked at. That's where we are getting. How did you get triangle for cos of 45? It came from the start. Okay. And what about 2? Still, we are applying. Anything we are doing now, we are applying from the previous knowledge. Remember, it is a continuation. Yes, Gertrude.
Good morning, sir.
Yes, good morning.
Sir, this part of sine 30, of course, sine is opposite that of hypotenuse. But here I see the hypotenuse, you have root 2, yet on the triangle, hypotenuse is 2.
I come here. What is the opposite? This is the opposite. And this is the hypotenuse.
Oh, okay, now get it. Here we were now converting the cos of 45.
Okay. Jovan? Okay. Jovan?
Yeah, good morning, sir.
Morning.
My question was, is it that we are going to use these angles we are using here? I mean, these triangles we are using here. In every question, we are going to use such angles.
Yes. Yes. That's why we call them special. Whenever you are going to be finding 30, 45, 60, these triangles apply.
Yeah, okay.
So for you, the moment you find 30, 45, 60, those three special angles, always these triangles will apply. Okay.
Okay,
Yes,
so
Alison?
whenever they ask such...
Now, teacher, I was asking you that during that part where you have rationalized, do we only take that number under the root sign and then we leave the constant, that 2? Or
Even
I
if
thought we had to take both.
even if you take both, there is no problem. Even if you do like that.
All right.
Still, you get 1 times 2 root of 2, you get 2 root of 2. 2 times
Yes.
2, you get what? 4. Root 2 times root of 2, you get 2. So you'll end up with this 2 and the 2 cancelling, so you get root of 2 out of 4.
Okay.
Okay. Joshua?
Master, for that part, I'm not understanding why you're having a half times 1 out of root 2.
We are substituting what sine 30 is and what cos 45 is. Sine 30 is the same as 1 out of 2. Cos 45 is the same as 1 out of root of 2.
Oh, it was multiplying. Okay.
Yes.
Thank you.
Okay. Techno? Okay. Okay. I think we are going to continue. Members, whenever you find these special angles, the moment you see 45, you see 30, you see 60, run very fast to these triangles. We go to another one. So allow me to clean my screen. And now we go to the next one. Now, when you look here, there are quite many, but we are going to only do 3 or 2. In fact, we are going to do 2 of them. Can you quickly do for me part A, everyone? Place your angles very well. Always come up with those triangles, and with the time, you'll be able to get them in the head. So we are doing part A. I'll ask someone at a later time to raise up the hand and you take us through part A. Yes, Cyprian? Okay. Cyprian, I'm not getting you. Tekino? Okay. I'm also not getting Tekino. Okay. Someone who wants to take us through part A, feel free to raise up your hand. Okay. Joshua?
Yeah, to take you through part A. So part A is sine 30 cos 60.
Okay.
So sine 30 is equal to opposite over hypotenuse. We are using the second triangle.
Okay.
So that sine 30 is equal to the opposite to the angle 30 is 1 and the hypotenuse is 2.
Okay.
So therefore sine 30 is a half. Then cos 60 is cos 60 is adjacent over hypotenuse. That means cos 60 is equal to the adjacent to 60 is 1. And the hypotenuse is 2.
Okay.
So now we multiply sine 30 times cos 60. So that is a half times a half. Half times a half is 1.
Come again? Come
Half
again?
times a half is a quarter.
Hey. Okay. Okay. Thank you, Joshua.
Right.
Okay. So, members, that's how you deal with that. Nancy, unmute. Nancy, unmute. Okay. Daniela?
Teacher,
Yes.
good morning, teacher.
Morning.
Teacher, I thought for 60, yeah?
Mm.
Since the 60 was in the equilateral triangle, so we consider that 2's where we put on the sides. So I thought when you're getting the adjacent and the hypotenuse, the answer will be 2 over 2.
Okay. Daniela, you stay on. If this is your triangle, yeah? And this is where
Yeah.
60 is,
Mm.
When you look at this triangle, what could be your adjacent on A,
Say
B, and C?
2.
It will be which side? I have A, B, and C.
A.
A.
So,
Yeah, it is true. But Danila, don't forget we say that to get adjacent, hypotenuse, and opposite, always we must deal with a right-angled triangle. This whole triangle is not a right-angled triangle, so there is nothing we can do about it. I don't know that you're getting it.
yeah.
So that's why we have to cut out. So what we cut out is what forms our right angled triangle, so we can now confidently use it.
Thank you, teacher.
Okay. Okay. Daniela? Daniela, are you still on? Okay. Okay, I'm failing to get her. Can we have someone to take us through now? Part B. Part B. Annette? Annette, unmute. Oh, I'm failing to get Annette. Okay. Arajab?
Sir, good morning.
Good morning.
I'm going to take through part B. Here we shall consider our triangle, first triangle.
Okay.
By sine 45 will be equal to 1 over what? Over root 2.
Okay.
So now we shall have 1. So sine squared 45 degrees will be 1 over root 2 squared.
Everything squared, yeah?
Yeah, everything squared. So now there we shall have 1 over root 2 squared. It is the same as 1 times 1 over root 2.
Okay.
We shall have a half.
Okay. Yeah. Thank you. Thank you. Yes. Thank you, Arajab. Alison, any questions?
No, I just wanted to take you through, but the other one
Okay.
has taken.
Okay, Alison, no worries. Alison, we are going to run together through part. Which part do people want? In the chat, members choose one part we are going to do. Then the rest will be yours. Which part? I'm going to take the first. Okay, people are saying F. Good. So Alison, we are going to go to run through together part F. So, Alison?
Yes, now members, they have told us that sine squared of 30 plus cos squared of 30 divided by 2 sine 45 cos 45. So members, you first rewrite that thing, we first solve for that we are going to first solve that, but you are going to first use those things that are on the numerator, and of which sine squared of 30, and we know that sine 30 from our second triangle, sine 30 from our second triangle, sine 30 is what? Opposite over hypotenuse. And our opposite here is the 1, and our opposite is the 2. So we say a half, but everything squared, plus, now cos 30. We know that from our cos 30, we are also going to use triangle 2. And you know from our cos is adjacent over hypotenuse. And here our adjacent is a root 3 over our hypotenuse, which is a 2. So we say root 3 over our hypotenuse, which is a 2. And everything here is squared.
Okay.
So we divide this by 2 into, So 2 into we have sine 40, sine 45. So sine 45 members, we are going to use triangle 1. And we know that our sine is also opposite of our hypotenuse. And our opposite here, using triangle 1, our opposite is the 1. And our hypotenuse is the root 2. So we say 1 over root 2. All right. So this bracket is multiplied by another bracket, which is cos 45. And you know that cos 45, we use the first triangle. Cos 45, from our cos, we know it is adjacent of our hypotenuse. So our adjacent here is a 1, and our hypotenuse here is a root 2. So our adjacent is a 1, and hypotenuse is also the root 2. So members, these 2 has to multiply these 2 brackets. So you can put a very big bracket on them, showing that the 2 multiplies everything after getting a product of those things that are after getting a product of the 2 brackets. So members, from this, we know that when we bring up this square, when we get the square, a half squared, when it is in a bracket, half divided, but everything squared, we are getting 1 over 4. So solving for the numerator, we get 1 over 4 plus 1 over 4 out of. So members, when you solve for this bracket, when multiplies this bracket, you find out that we are going to get 2 into 1 over. So when you get root 2 times root 2, we know that we are going to get a root 4. And root 4, the square root of 4 is a 2. So inside we get a half. So everything when is multiplied by 2, we know that we are going to get a quarter plus a quarter. What do you get, members? So a quarter plus a quarter, we know that we shall get, let me first add here, a quarter plus a quarter. All right, members, I get a half. So if I get a half, a quarter plus a quarter, you get a half. This a half is divided by. So members, when you multiply these 2 inside this fraction that is inside, we get 2 over 2. And that 2 cancels with that 2 down. So our denominator becomes a 1. And of which, when it is a 1, a half divided by a 1, we get our answer as a half.
Okay. There is something, Alison, you forgot here when it came to squaring. I don't know that you noticed something when you were squaring.
Hey, all right. Yeah, I forgot. I made a mistake there. So here I tried to be a theory. Yeah. Thank you, sir.
Okay.
So here I tried to be a theory. Then from our addition, when you add a quarter plus a third plus 3 out of 4, a quarter plus 3 out of 4, we get a 1. Okay, thank you, sir.
Okay. Okay. So, members, are we on the same page? Anyone that is lost? Shadia, Kolido. Okay. Daniela, anyone that is lost? Members, let me know through the chat whether we are good to continue.
Teacher, on my 2 sine 45 degrees, because when I got the opposite over hypotenuse on the sine 45 degrees, then I multiplied the 1 over 2
Did you do it
times
like
the
this,
2.
Daniela?
Well, I got 2, but yes.
Yes?
Yes, teacher.
So root 2 times root 2, Daniela, what do you get?
Shall you get 2?
So by 2, 1 by 2, 1.
Oh, Okay. Thank you, teacher.
Okay. Lastly, Shadia. Okay. So members, for the rest of the numbers, take a screenshot. You'll respond to them. You'll respond to them at a later time. Okay. So Shadia, I failed to get you, but we are going to continue. So members, that's how you deal with that. So now we are going to deal with what we call the general definition of angles. Now, when it comes to trigonometry, I want you not to do, there are two things. At O level, you looked at trigonometry, you looked at bearing. Many times, children usually confuse bearings and trigonometry, but those are totally different things. Now, when it comes to trigonometry, when it comes to angles, we measure angles from the positive x-axis. This is your x-axis and this is your y-axis. Now, when we are measuring angles, we shall always place our protractors in this format. That is how you place your protractor. What does it mean? It means that your zero will start from here, then you go to your 30, 40, 80, and 90, up to 180. This is how we place our protractor. Now, that means that your 0 degrees starts from here. And which direction do we take? We always move in this direction here. So all angles that we measure in the anti-clockwise direction are positive angles. This is how we move the axis. So when you are measuring the angle, the moment you get a positive angle, it means that that person is moving in the positive x-axis. The moment someone writes 30 degrees, it means the person is starting to measure his angles from 0 going in the anti-clockwise direction. But if someone writes negative 30 degrees, now negative shows that someone is measuring angles but in the clockwise direction. That is when someone will come here, you place your protractor in this format. So negative 30 degrees is an angle here. It means that the direction you are taking is the clockwise direction. But always when we are measuring angles, we start from the positive x-axis. Members, have you understood that concept for angle measurement? Okay. Now, when you look at what I have, we have quadrants. Quadrant means quarter, that something has been divided into 4 equal parts. Now, this is what we call the first quadrant, second, third, and fourth. Now, I'm going to write my angles, and you are going to use your estimation. Remember, this is 0, this is 90, this is 180, 270, and then lastly we come back to 360. Now, I'm going to write an angle, and you are going to tell me the quadrant where that angle lies. Let me say, when I write 45, you just tell me that is in the 1. When I write negative 45, you tell me that negative 45 will lie in the 4th quadrant. That's what I'm saying. So I am starting. You type in the chat, me I'm going to be looking there. And I will say that now you have understood, because that one is going to show me that now you know where angles, you can estimate where angles are found in the different quadrants, and now you can distinguish whether it is clockwise or whether it is anti-clockwise. Now the first one is 95. Just put for me the quadrant 1, 2, 3, 4. Perfect. You are very good. The next one is here. I've put for you another one. Now here I'm testing. Have you understood? In case you find a negative 130 degrees, here we have not yet understood. I'm seeing answers are varying. Some are saying 3, others are saying 2. Now the 3s are many. Very good. Very good. Yes, members, we have said negative means you are moving in the clockwise direction. So you place your protractor like this. So you notice that 132 is going to be somewhere here. So that angle is here. So that angle will be in the third quadrant. Let me hope, Kathy, you have understood that. The moment you find a negative on an angle, it means that that angle was measured in the clockwise direction, but from the positive x-axis. I put another one. I put another one. I have another one. Very good. Very good. Very good. Very good. Now, someone is still putting another answer. You need to know that this is where 270 is. So you estimate. Okay. Okay. Now, if I don't get any person who fails this, I will know that we have understood. Yes? 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 If I don't get anyone who fails this, I know we have understood now. I'm starting to count from. Someone has put another answer. We are still having mixed reactions here. Someone has put Okay. I want someone now to just raise up the hand and you explain in your own words the way you have understood such that also others can pick. Edida.
Okay, good morning, sir.
Yes, good morning, Edida.
So in the way I've understood it,
Mm-hmm.
if we limit ourselves to only 180, everyone is going to get confused.
Mm-hmm.
So me, I've understood it as all my angles, if I want to make them, if they are negative, all my angles will start from 0, where there's the x-axis.
Okay.
Then I'll be moving anti-clockwise up to when I come back to 360. Of course, where there is a 0, there's a 360.
Mm-hmm.
Yeah.
Repeat
So
that
I'll be
statement.
moving where there is a 0.
Mm-hmm.
On that same position, there's 360.
Mm.
Of course, when you rotate around the whole quadrant.
Mm.
So me, though I've understood, if it is a negative, you're going to be moving in the clockwise direction up to when you reach 360. So it's how you find. So it's how you find your 240 exceeds 180 and to be in the second quadrant.
Okay, perfect. Thank you, Edida. Yes.
Welcome.
Okay. Hope everyone. Now let me put the last one. The last one. Members, make sure you don't fail this one. If everyone gets it, I will know that we are there. Just place in which quadrant is your answer. I've started. Someone has spoiled the thing. The quadrants, members, the quadrants, they are constant the way you see them. This is the first, second, third, fourth. They don't change. Someone has spoiled it. Someone has spoiled it. I've seen an answer different. But I'm happy that many of you now have got the concept that we measure. So can you summarize in your own words? Let me give you 1 or 2 minutes. Just summarize in your book the way you have understood angle measurements, how we measure angles and which direction. It's going to be important. Yeah. But Shadia, your hand is still up. Okay, okay. Members, have you finished to summarize in your own words? You just continue and then we proceed. A minute, okay. Okay. I'm waiting for more to three people. Always learn to summarize. Even if the teacher tells you something, always put it in your own words. The way you have picked it, the way you have understood. You write in your own. Write in your own words that maybe this and this. Yes, Abenaitu. Okay. 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 Abenaitu, your hand is up.
Good morning, sir.
Good morning.
For these quadrants, I'm now okay, but the other time when we were talking about on the previous assignment that man was doing, I think the two was affecting only sine 45, but not even cos 45 because there were no brackets.
Okay.
But
Abenaitu,
yes.
what is your answer here?
Where? That one you
Here,
have
are you
written?
seeing what I'm writing?
Yes, 2 times 3. It is 6 over 2.
Which is?
3.
Which is, Now, what we had was 2 times 1 out of root of 2 times 1 out of root of 2. Not so?
It was
2 cos of 45, sine of 45, something like this. Hope you know that this is multiplication of two things.
Yes.
Which is the same thing like here. So it is, when you relate it back, relate it to this that you have done. That you have multiplied 2 times 3 times 1 to get 6.
You get it the same.
Yeah?
I have seen it now.
Okay. So members, let's now continue. Okay. Now, this is where we are going to start. They have asked us that draw a diagram showing the quadrant in which the rotating line OP lies for each of the following angles. In each diagram, indicate clearly the direction of rotation and state the acute angle that that line makes with the x-axis. I'm going to start with A. Now, we have said that when they talk about 100 degrees, I'm going to come, I draw. Remember, this is 0 degrees, this is 90, this is 180. Now, they want us to show the quadrant in which the rotating line OP, rotating line is this line that I'm going to show you the rotating line. Now, we are going to indicate 100. So you do notice that 100 is going to be somewhere here. Now, the angle we are remember we are rotating 100. This is 100 degrees here. And this is line O to P. Now, take note that this is your first. Let me make this long enough such that people can see. So they want us to indicate line OP, which is this line here I have indicated, showing the direction of rotation. Now, the direction of rotation is the clockwise and clockwise, positive or negative. So the direction we are taking here is the anti-clockwise direction. And then 2, state the acute angle. Yesterday we looked at the angles. Members in the chat, give just one example of an acute angle. Put it in the chat. to check. HPS, perfect. Yes. So they want us to get the acute angle. The line OP makes with the x-axis. Members, I want you to take note that this is what we call the x-axis. This line here is what we call the what? X-axis. Now, whenever you are looking for the angle it makes, always look at the angle that is near it. Now, members, the angle near the x-axis is this angle here. And that is the angle we are going to find. So which angle is here? When you look at the angle you have here, you ask yourself, how many degrees are we remaining? If we have stopped at 100, how many degrees are we remaining with here? Put in the chat what is the answer. Very good. So the angle we have here is 80 degrees. So that's how we are going to do it. So the angle it makes with the x-axis is 80 degrees. And this is the sketch for that diagram. I do one more. I'm going to do let me do part D. When you look at part D, I'll still draw my axis. The angle I have here is negative 150. But we say that negative means that I move in the clockwise direction from the positive x-axis. So I'll move. Remember, this is like 90 degrees and this is 180. So I'll move up to somewhere here. So this is where we have our angle of 150 degrees. Now, when you reach here, which angle is close to the x-axis? This angle here, members. Tell me in the chat, which angle will that be? Members are noticing that that angle is going to be 30 degrees. So here, the angle that is close with the x-axis is 30 degrees. Members, have we understood what to do? Is that okay? As I pick on a hand, then be doing part B and C as I respond to questions. Yes, Nancy? Okay, I'm failing to get Nancy. Trinity? Oh, I'm failing to get Trinity.
Okay, I have a question.
Okay, yes, ask.
For part A, I thought our answer is meant to be negative 8, not only 8.
Oh, you thought it's going to be?
Negative 8.
Why negative 80?
Because remember you said what? When you're measuring, we begin from the x-axis, right? And when you put our protractor on that line to measure the remaining angle, it will be in the clockwise direction. Because remember you said you have to show the direction of the arrow. And the angle is beginning from the x-axis to that line.
Oh, now here we are only looking at the angle that is close to the x-axis without looking at the direction, because they told us state the acute angle that the line OP makes with the x-axis. This is the line OP and this is the x-axis. So the angle that it is making here is just 80 degrees.
So we don't consider the signs?
No need for the signs.
Okay, thank you.
Okay. Wabi?
Okay, teacher. It was somehow the same question because when I tried out part B of negative 100 degrees, I also had to get 80 degrees.
I think you are going to type. You are going to type. I'm not getting you. Okay. Wabi, you can type. I'm not clearly getting you. Okay, so from the chat, members are telling me that part B, they have obtained 80, and for part C, they got 50. That is what I'm learning from the members. Okay, which is okay. Thank you, Tracy, Abenaitwe, Google, Mercy. Okay, let's finish. Oh, no, we are just looking at the angle. We are not looking at the direction because clearly indicate the direction of rotation. You have indicated the direction already. So that's why we don't put the 30 into consideration. You have indicated that you are moving in this direction. Yeah. Okay, so we are going to continue. Is it Levis? Unmute. Okay, so we are going to continue. We are going to continue. Okay, so I have another activity here. Okay, for each of the following diagrams, find the basic angle theta. Do you know the basic angle? Now, any angle that is always close to the x-axis, we call it the reference angle. Reference angles are going to be very, very important. Now, take an example. When for the diagram we have had, the previous diagram we have had, the diagram which had 100, this angle that is very close to the x-axis, we call it the basic angle. So it was 80. If for the other second one we had around here, this angle that is close to the x-axis is called the basic angle. In other words, if I have, let me say diagram like this, the angle close to this x-axis is always called the reference angle. This angle here is what we call the reference what? Angle. In case it is in this format, the angle here is called the reference angle. The angle here is called the reference what? Angle. So whenever you are talking about a reference angle, you are talking for what angle is very close. 110 is close, but it's not the closest to the x-axis. So always you must look out for that angle. A case in point, when you look at this angle here, this is the angle closest to the x-axis than the 110. So I want you for each of these diagrams, can you find what is the basic angle? What is that angle that is very close to the x-axis? So find for me theta for each of those diagrams and put your answers in the chat. Please, you must be able to get that basic angle. That basic angle, people are saying 70. Good. Continue. Genesis.
Mr. Kazuwa, could you please pardon on that part? I've not gotten it well.
Like, the reference angle is always measured from the x-axis, but it is that angle that is the closest to the x-axis. Take an example. In case I have here, this is my diagram, and I have an angle moving like this. The angle very close to the x-axis here is what we call the basic angle. Have you got it?
Now,
yes?
Okay, you're taking an assumption people are getting 70 on A. How is it
Yes.
coming?
Now you ask yourself, from here up to here, you notice 180, not so?
Yes, teacher.
Now you ask yourself, what angle is here? Because when you look at this angle and the angle you have moved, which one is very close? Is it here or it is B? This angle here.
It is A.
It is A. Now you ask, how many degrees is A making? For you to reach 180 along the x-axis, how many degrees do you need to move? Are you getting it?
Yes, teacher.
So that means you will say 180 minus 110, which will give you that 70 degrees.
Oh, I've understood. Thank you, sir.
Okay, don't run away. Come back. We on part C. Are you seeing part C? Genesis.
Yes, teacher.
We on part C, not so?
Yes.
You tell me which angle is going to be close here to the x-axis here.
Let me see. 20. 20.
20. How did you get 20?
Okay, I get to know that here it's 180 and they moved 200 degrees. So the closest I subtracted 200 degrees minus the 120. 180.
Okay. Kale, thank you.
Thank you,
Now you are
teacher.
there. Okay, Hannah?
Yes, sir, on part D.
Part D?
Yes, the theta first moved, yes, the 360 degrees. Then after it moving 360 degrees, it again, what I'm asking, did it add the 140 degrees from 360 going anti-clockwise?
Yeah, because you are saying yes, it is anti-clockwise.
So
This was the first turn. Are you seeing the first turn?
Yes.
And then he continued the second turn. So you tell us the reference angle. So the reference angle should be this angle very close to the x-axis. Which angle is that? Don't go away, Hannah.
The reference angle is 140.
No, remember, Hannah, are you seeing he has so far moved again 140? Now you ask yourself, if this is the reference, you have moved so far 140. You ask yourself, this angle here and the angle you have moved, which one is going to be very close to the x-axis? The smallest one.
Oh, so the reference angle is 40.
Is 40. Very good. How did you get 40?
Getting 40. I subtracted 180.
180 minus 140.
140.
Okay, perfect. Yeah.
Okay, thank you very much, sir.
Okay, thank you. Yeah, so members, that's how you attempt. And I want to let you know that reference angles are going to be very key when you are solving trigonometric functions. Because your reference angle is going to be supporting you to determine other angles within that particular quadrant. In order for you to know other angles, because at this level, we shall not only be giving one answer, we shall be giving very many what? Answers depending on the quadrant where our thing lies. So make sure you know how to find the reference angle. And in summary, let me see whether I have a summary. Oh, unfortunate. Oh, where have I gone back? Okay, yeah. Unfortunately, I don't have a summary, but we are going to come up with a summary. But one thing you have noted that when you reach in this quadrant, in order for you to get the angle, you always said 180 minus 110. That's how you got the angle. In this quadrant here, you said otherwise. What did you say? Here you said 360 minus the angle you had of 320. When you came to this quadrant, you noticed that now you had to say 180 minus the 140. Here, that's what you said. When it came here, you notice that you got 200 minus 180. Now, whatever thing you are going to be working on, you are going to notice that there is something we are going to come up with at the end of the day. Now, we have what we call trigonometric ratios for the general angles. Now, when it comes to these general angles, I know you have already summarized them at O level, and we are going to summarize them like this. But I wouldn't want you to... okay. Yes. Any angle, the sine, the cosine, and the tan have a way they do lie. I'm going to show you one. Take an example. Like I've said, I wouldn't want you always to cram. I want you to understand the basics. When I am in this quadrant here, and I have the always, I want you always to refer to the reference angles. You know that this is the positive x-axis. You know that this is the negative x-axis. You know this is the positive y-axis, and this is the negative y-axis. Now, when you check here, in case this is our triangle, this is your y, this is the x. This is positive x, this is positive y. And this one can be our r. Now, in order for us to get any, let me say theta, to get the sine of theta, you know that sine is going to be given by always opposite out of the hypotenuse. So you notice that sine is going to be opposite, which is y out of r. That one, you know it. So you are going to notice that your sine is going to be positive, your cos is going to be positive, and then the other one is also going to be positive. But when it comes to the second quadrant, what do you notice? That this is positive y and this is negative x. Now, when I draw my triangle like this, this is the reference angle. This is going to be negative x. This is going to be positive y. Then this one is going to be your r. What are you noticing? You are noticing that in case I come in this quadrant and let me say I want to get sine of theta. What is sine given by? I will say that sine is opposite. Remember, this is opposite, hypotenuse, and this is adjacent. So sine is given by opposite out of the hypotenuse. So sine is y out of r. So meaning that here you notice that you get a positive answer because r is this. When it comes to cos of theta, cos is given by what? Cos is adjacent. So you notice that adjacent out of the hypotenuse, which is r. So you notice that cos is negative. The answer you get is negative. That's why in the second quadrant, we always say that cos is negative. When it comes to tan, you know that tan of theta is given by opposite, which is y, out of adjacent, which is negative x. So you notice that the answer you remain with here is going to be negative y out of x. That's why here tan, we shall always say that tan is negative in this quadrant. Members, let me know. Are you understanding what we are doing? Are you understanding the concept? I'm trying to show you why do we say that cos is negative here, tan is negative here. Are you getting the concept? Okay, perfect. Let me now show you one more. Now, in case I'm going to use the last quadrant. In case I'm using the last quadrant, always it must be with reference to this angle here, the reference angle. You know that this is y, but you know that this is negative y, so this is going to be negative. But this is positive x, and this is your r. So when members, I come here and I say I want cos theta. Cos theta, you know that this is the opposite, this is the adjacent, and this is the hypotenuse. So you know that cos is given by adjacent out of hypotenuse. So cos is positive. But when it comes to sine of theta is going to be given by opposite, which is negative y, out of hypotenuse, which is r. So you notice that sine is negative. That's why we say that in the fourth quadrant, sine is negative. So that's how it comes about. Yes, Samsung. Okay. Members, are we on the same page? I want now to continue. So even tan is negative. Tell me, are we good to continue? Okay. People are saying now we can continue. So now when we come here to summarize, that is how you can summarize. So summarize your things. Summarize in your table. Show now. Yes, I know you remember that here, sine, cos, and tan, all of them are what? Positive. Here it's only sine. Cos and tan are negative. Here it's only tan, the others are negative. So can you summarize? And I know you have your mnemonics you use. So feel free, in case you have any mnemonic you use to remember, you can place it in the chat such that, HP has said all students take cake. All science teachers complain. All students take care, okay? Yeah. And then for you put your mnemonic you want to use to remember. Acts, Acts, all science teachers cane, okay. All science teachers cane, all student teachers cane, all science teachers cane, all science take chemistry, all secondary. That one I don't know. All science teachers care, okay, okay. Yeah. I think everyone has his own, but that's okay. That's okay. Eh, okay. Okay, okay, okay. All right. Okay, yeah. So use any mnemonic you want. So we are going now to continue. Now I've brought in two concepts, reference angle, and now I'm going to bring in the quadrants. Now we are going to start. Now they want us to express in terms of trigonometric ratios the acute angle. Acute angle. We say that acute angle are those angles between 0 and 90 degrees. What are we going to do? Here, I want you to understand those sketches. So I'm going to come. I draw my sketch. I know this is 0, 90, 180, 270. Now I estimate where is 140 lying. Now check out the angle you have. That the angle you have is a positive angle. Is that fine? That it is a positive angle. Now, since it is a positive angle, you know that all S, T, and C, it is a positive angle of 140. So you remove 140 is going to lie here. So this is your 140 degrees. Why have we taken this direction? Because we know very well that our angle positive, we measure from the positive x-axis and then we go in that direction. Now they want us to express it in terms of an acute angle. An acute angle means an angle between 0 and 90. Now, always get the reference angle. Any angle close to the x-axis. Members in the chat, tell me what is our reference angle. Reference angle is that angle closest to the x-axis. What is that angle we have there? People, 40, very good. So the angle we have here is 40 degrees. Now 40 is what we call the reference angle or basic angle. Now after obtaining the angle, the next question you are going to ask is, I have sine. In this particular quadrant, what is the sign of sine? Have I pronounced it well? Yes. What is the sign of sine? That the sign of sine is a positive because sine is positive. So members, I'm going to come here and I say that in terms of the acute angle, sine 140 is the same as sine of 40 degrees. So I don't need to put degrees here. It's the same as 40. Members, tell me whether you have understood that. I have left it as positive because sine is positive in that quadrant. Understood? Okay, Claire?
Good morning, sir.
Morning.
Sir, I'm asking, why don't we put degrees on the 40?
Oh, under 40. Why you don't put
Yes.
degrees? We can put,
Yes.
no problem.
Okay, thank you,
Since
sir.
here since in the question they had given us, that's why I can put it.
Okay.
Okay. God is child. But clear, let me also make it clear. When you find that they have not put degrees, then you need to take into consideration what we call radians. But I will bring it at a later time.
Okay.
Yes, Junior?
Sir, can you repeat that concept of sine of 40 is equals to sine of 140?
Now, okay. The first thing always, okay, let me use part B. Now, when it comes to part B, the first thing you need to ask yourself that the angle is negative 130. How are you going to move? I'm going to move in the clockwise direction. So I'll come here. I move my 130 is somewhere there. That is 130 degrees. Now the next thing you ask yourself, what is the angle closest to the x-axis here? Members in the chat, tell me which angle is that is closest. Members are saying it is 50. So the angle you have here is 50 degrees. Now, the next question you are going to ask that you are dealing with cos. So you know that all students take chemistry. Now, the next thing you are going to ask yourself, in this particular quadrant, what is the sign of cos? That in this quadrant, cos is negative. I don't know whether that is okay. Now, after knowing that cos is negative, what does it mean? It means that the answer you are going to write, is going to be now. Since cos is negative in this quadrant, I'll write negative, but I write cos of 50 degrees. The negative here is showing him that in this particular quadrant, cos is negative. But my reference angle is 50. So when you place your calculator, cos of negative 130 is the same thing as negative cos of 50. I don't know whether you have understood. Was it Sembatia? Have you understood? I think it was Sembatia. Sembatia, have you understood? It was someone. Yes. Members, have we understood the concept?
Yes, sir.
Arajab? Okay. Arajab, is it a question?
I just sir, what if when you do cos of negative 130 degrees, you say that is equals to cos, then into brackets 180 minus 130, then you get cos 50, and you apply a sign. Don't you get the same answer, or that
Yeah.
alternative?
Yes, you get the same answer. But how does that thing come from? That's what I'm showing you. That's why I always want you to learn the basics. You need to learn how does it come about.
Okay, sir.
And when you look here, that you have even a sketch. So here, you are not cramming a lot of things in your head, but you are understanding from the basics. That's what I'm looking at. Okay. ZT. Okay. Kathy?
Sir,
Ruth? Yes?
I was asking that is negative cos 50 the same as cos negative 50?
You're asking, is cos of negative 50 the same as
negative cos of 50
negative cos
degree,
of?
50
The answer
degrees.
is no. Is that okay?
Why?
Why? Yeah, because when you place your calc, cos of negative 50 and you place negative cos of 50, you'll get a different answer. Have you tried it? Yes, you try it. You'll see that the answers are different. But that one, I'll bring an idea about it when we reach the graphical work. Yes, Ruth?
Excuse me, sir. We have said that we are moving in the clockwise direction, and our angle close to the x-axis is 50. So the fact that it is clockwise, doesn't that automatically make the 50 a negative, or?
Oh, no. 50, a reference angle doesn't have it doesn't have like negative or positive. It will always be positive, your reference angle.
Okay.
But
So
now
if
the signs, come again?
Now if it was maybe in the anti-clockwise direction, maybe if it was like negative 260, and
Give
it was
me what, if it was, give me the thing you want. I write.
I have negative 260.
When it is what? Cos sine what?
When it is sine.
Sine. So you'll
Yes.
come here. You know that you'll move here. So it is going to be somewhere here. That is the 240, right? Now you ask, which angle is here that is very close to the x-axis? Which angle is that?
Only 30.
Sure. Remember, don't forget this is 180. So anything that comes should be able to give you the total thing.
So I'm confused.
No, like you have moved from here up to here. You have moved 240. Not so? So what do you remain with to make it 240 here? Because here you know already it is 180.
60.
60. Is that fine? Now, sine of negative 240 degrees. In this quadrant, you are going to say that all students, that sine is positive. So you'll say sine is positive. But the angle you have here is 60. So since sine is positive, I write a positive sign, then I put my reference angle. Are you getting it?
Yes, sir. Thank you.
Yes. So when you place sine of negative 240 and the sine of 60, you'll get the same thing.
Okay, thank you, sir.
Okay. So I think members hope you are getting it. Your reference angle will always be positive, no matter the direction you are taking. But the quadrant where it falls, it will determine the sign of the trigonometric ratio. Kerea, is it a question, Abenayutwe? Members, you are doing for me. She has given us part C. My part D is here. Get for me the answer quickly.
Master.
Yes.
Now my question is, are you hearing me, sir?
Yes, I'm hearing.
Like you are for the course of 240. When you are, because course for 240, I've seen that it lies in the third quadrant, and where it is a negative in the third quadrant. And remember, I've said cos 240. So I'm getting confused because
this was negative 240.
No, I'm not meaning that one. I'm bringing for the course of 240.
Oh, okay, it lies here.
Then when it lies there, which means in that quadrant, it is a negative.
Okay, we first find what is your reference. All? Yes.
It lies in the third quadrant.
Yes.
Then lying in the third quadrant, what does it mean? It means that the course is negative.
Negative. So, but what is the reference angle here?
In that quadrant,
Here.
it is 60.
60. That means that cos of 240 is the same as negative cos of 60. Once you press your calc, you get the same answer. That's what we are looking for. Understood? Have you picked?
Yes.
Yes. And now, where are we heading? In fact, now we are going to reach a point where now we are going to bring in issues concerning the special angles, because here someone can even go on and tell you, let me say, now like our brothers given us cos 240. You may reach there and they tell you that you have remained with cos 240, and maybe they are asking you to write it as an exact form. So that means you need to know that this is the same as negative cos of 60. Then you remember your special angles, that now this one is going to be negative root 3 out of 2. Is it negative 3 out of 2 or not? It is a half. In fact, negative a half. Yes. So you need to remember that the idea. So that is where we are heading. Okay. Members, let me know through the chat whether we have understood and we are good to continue. Yes, Claire?
You've not.
Yes?
Teacher,
Yes, please.
like you say that cos negative 50 is not equal to negative cos of 50. I'm now confused why we say that cos of negative 30 is equal to negative cos of 50.
Come again? Why we say?
You say that cos of negative 50 is not equal to negative cos of 50.
Yes, just press the calc. You'll get different things.
Now I'm confused why we say that cos of negative 30 is equal to negative cos of 50.
Why we say cos of?
Cos of negative 30 is equal to negative cos of 50.
No, it is cos of negative 130.
Yes.
Is equal to negative?
Cos of 50.
Yes, those two things are equal. The angles here are different.
Okay, teacher, why is cos negative 50 not equal to negative cos of 50?
Now, those two things mean different. Cos of negative 50, I told you it means that I'm going to move in this direction. Are you saying that?
Yes.
That is the meaning. Whereas negative cos of 50, it is something different. You move this side.
Okay.
But to make it much easier, for you just get your calc, you place cos of negative 50. See which answer you get. Place negative cos of 50. You'll find that one is positive, another one is negative.
Okay, thank you, sir.
Yes, so those are two different directions you are taking. Remember, I told that you need to be very careful. Whenever you find an angle with it, this one shows you the direction you are taking. When the angle is positive, you are moving in another direction.
Yes, thank you, sir.
All right. Now, okay. Now we start. Now we have started now solving equations. Now they have given us that we have, now here you are going to be very, very careful. They have given us to solve cos of this. Cos of negative is equal to negative 3 out of 5. Now, always you need to know, they have told us that this angle they have given us is between 180 and 270. You need to know. That's why I'm telling you, you need to understand that this is 0, this is 90, this is 180, this is 270. What does it mean? It means that when you are drawing, when you are coming up with your sketch, you need to have it in the right way. So your sketch will look like this. That's how your sketch will look like. And now this one is going to be your theta. Now, from your knowledge of Katoa, you know that this is adjacent and this is hypotenuse. So you will label your adjacent here as 3 and then your hypotenuse is going to be 5. Now, what are we wanting or what are we finding? Now, you know that in this quadrant, all students take the coffee thing. Now, may I ask each one of us to first get this side here? First come up with this side. What do you get? Calculate this side. Use your knowledge and calculate.
I'm wondering why we draw the triangle in that.
No, the triangle is to help you understand. It is to understand because it is very important because they want you to find the value of sine theta and tan of theta.
Teacher,
Yes?
why did we draw the triangle in this quadrant where tan is negative? I mean where tan is positive.
Yeah, because what they gave us was cos, not so?
Yes.
And you know that cos is clearly negative in the third quadrant and the second quadrant. Is that okay?
Yes. Yes.
But they have told us that the angle is between 180 and 270. So 180 and 270 means that now our triangle is going to be in the third quadrant.
Okay, I understand now.
Okay. Madra? People are getting 4. Good. So members are getting 4. So a squared plus b squared is equal to c squared. So this is 3 squared plus b squared, which is equal to 5 squared. So b squared is equal to 25 minus 16, which is 25 minus 9, which is 16. And therefore b will equal to 4. So that means here we are going to have 4. Now, they have asked us to find the value of sine theta. So members, this is where understanding is important. So sine of theta is going to be, remember from your saw, that it is opposite out of hypotenuse.
Hypotenuse.
So what is your opposite? For this angle?
It's 4.
It is 4. What is the hypotenuse?
5.
5. Then next, what is the sign of sine in this quadrant?
Negative.
Negative. So I'm going to put here negative. So that is your sine of theta. We go to tan of theta. So tan is given by opposite out of adjacent. So what is our opposite? 4. Divide by adjacent, which is 3. Then the next thing you are going to ask yourself, what is the sign of tan? That in this third quadrant, tan is positive. So we shall leave it the way it is. And now those are the values of sine theta and the value of tan of theta. Now members, are we on the same page? But the square of 16 is positive 4 and negative 4. Yes. So remember this is the negative y-axis. So the best answer you could have taken could be negative 4. Okay. Are we on the same page? In case you have a question, you may ask. XXI.
Teacher.
Yes.
Good sir. Why don't you put the negative sign on that way when you've drawn the triangle?
No, it is okay. You can put it there or you may not. So if you put it there, let me draw the triangle here.
Yes.
let me put the triangle here. So if I put it here like this, let me draw. Sorry. There are two ways you can do it. You can put it there or you may not. I have no problem. Now, in case you have put it here, this will be -3. Now, this is going to be -4, and this will be 5.
Yes.
So, if you want, you could do it like that. The only thing now you need to remember that this one being the y-axis, when you get this side, remember you get the square root. So you don't take in 4, but you instead take -4. So here now you'll come and say, what is my sign? My sign is opposite
Sign
out of
is
hypotenuse. So -4 out of 5.
4
What
over
is your
5.
tan? Tan is -4 out of
-4 over
-3.
-3.
Yeah. So that is also okay. You can do it that way.
Okay, sir.
Okay.
Thank you, sir.
Okay. Let me pick on from Z something. Okay. In
I have the
case
same question. I've understood.
you have understood. Okay. What be Adrian and Bidion?
Okay, teacher, my concern is on the triangle you've just drawn in the quadrants there. When they tell us that the angle is in between 180 degrees and 270, does it mean that you have to draw that cut triangle there? Does it have to attach itself does it always have to attach itself on the x-axis?
No, it does. You may not do it as long as you have drawn as long as it looks like how it's supposed to look like.
Not really, teacher, but when you've identified that the angle is in between 180 and 270, and then you draw that OP line. The way you attached that OP line to the x-axis, can it attach itself as so to the y-axis, or it always has to attach itself on the x-axis?
Oh, always we start from the x here. We start from here.
Excuse me, sir.
Are you getting it?
Yes.
Because this is where now we start now separating that here it is positive x-axis. This is negative. This is positive, something like that.
Okay, teacher.
Excuse me, sir.
Yes.
Sir, is it a must that the answer here, like as we have got sign -4 over 5, that we should leave it like that, or you can go further to simplify?
Oh, like simplify too?
Like in decimal points.
Oh no, leave it in fraction form. Whenever you create a decimal point, you are making your answer not to be accurate. You are making more errors.
Okay, sir.
Okay. Any other?
Excuse me, sir.
Yes.
When does this 5 become negative?
Which
And
5?
if it this 5?
No, your hypotenuse can never be 5.
Okay. Thank you, sir.
Okay.
Excuse me, sir.
Yes.
Sir, I thought that the tan is the opposite of
Opposite out of?
adjacent.
Yes. That's what we have here.
The opposite is a -4, but I'm seeing a +4.
No, yes. Tan is -4. Divide by adjacent, which is -3. So negative divided by negative is positive, which is 4 out of 3.
Okay, thank you, sir.
Okay. Edgar?
How come, like, the adjacent was negative? Then
because
when you are substituting,
like I told you about the axis, you know that this is -1, -2. So the negative comes from that idea.
Okay, I now understand.
Okay. So members, allow me to display this activity. I need to look at my time. Take a screenshot of this. Take a screenshot now, quickly. This is what you are going to do. Take a screenshot of this. Hope members have finished to take a screenshot. Take a screenshot of this. Now here, this is where I want you to be very careful. When they say that without using, find the exact values of each of the following. So I expect you to first express this angle in terms of an acute angle, that this is 120. After getting 120, you know that here what will remain is going to be 60, such that you know that cos of 120 is the same as negative cos of 60. And then you go back to identify that cos of 60 from our special angle was equal to this and the other. And then you substitute in. Okay? That's what you do on that part.
Teacher.
Yes?
Teacher, I didn't understand how you did that.
Which one?
The cos of 120. Okay, I understood that. But then why you say that we have to substitute? How do we substitute that?
Cos 120. Like
yes.
From our quadrants here, you know it is going to lie here.
Yes.
Now the reference angle here is 60. But in this quadrant, you know that sine is positive, but cos is negative. So that means that cos of 120 is equal to negative cos of 60 degrees. Then you go back to the special triangles we had, where we had 60, 1 or 2 root of 3. Then you ask yourself, what is cos of 60? Cos is given by adjacent out of hypotenuse. So it becomes negative 1 out of 2.
Okay.
Yeah. That's what I'm saying. So that's what you are going to do on this part. Then this is your exercise as well. Now you see some of these words. Obtuse. Now you need to know that, obtuse, in which quadrant is this thing lying? Okay. Have you taken a screenshot? Have you taken a screenshot?
Yes.
Okay. M, why is the triangle in the tan region? Because of the angle, they specified the angle that was between 180 and 270 degrees. Okay, thank you, Gertrude, for responding. Because of the range, thank you, Jolie. Shaq, that is okay. Yeah, thank you, everyone. Okay. I think we are going to end here such that we can now go and do housework. So thank you so much for attending. Let's meet tomorrow.